So in this video, we're going to have a look at how we can apply our understanding of straight line or linear graphs into real world type situations. So the scenario we're going to look at here is we've got a jogger that's running at a constant rate of 6 kilometers per hour. Okay, here we go, 6 kilometers per hour. And they've gone for a run for 3 hours. So the first thing you have to do is you have to find the key bits of information that we need. So 6 kilometers an hour and 3 hours are our two key values that we're going to use for this question. So first thing we should probably do is draw a table of values, and we need to find variables to use to replace our X and our Y for our normal linear graph. So the two values, so we're looking at here, so we've got speed and time. What I probably would do is distance and time. And I'd use this because if you look here, that's a rate of change. How much is our distance changing? So it's changing at 6 kilometers for every 1 hour. So we're actually going to use that as our gradient. And we'll use, if you have a look at that rate of change, we've got two different units of measurement in there. We've got kilometers and we've got hours. So we can use those, so distance and the time. So we can use those as our X and Y axes. When we do something like this, we always use time as your X axis because we can't go backwards on the X axis and you can't go backwards in time either. But with your distance, you can go back. So if I start walking and then I decide to turn around and go back the other way, my distance from my original point is going to be decreasing. So let's draw a little table of values. And we're going to use distance and time. Actually, I'm going to use time in the top, time and distance. So let's go walking for 3 hours. So we can do, we just need to separate it into 3 blocks because they're only walking for 3 hours. Actually, let's separate it into 4 because we can use 0, 0 as our starting point. There, one there. Let's fix that table up. Let's go 0, 1, 2, and 3 as our time. So we've got our 0 hours, 1, 2, and 3 as well. So we need to find at 0 hours, how far have we traveled from our original point? We haven't traveled anywhere because it hasn't had any time to move. So that's still going to be 0. After 6 hours, we're traveling 6 kilometers per hour. After 6 hours, how far have we traveled? Sorry, after 1 hour, how far have we traveled? I kind of gave you a hint there. We've traveled 6 kilometers. 6 kilometers for every 1 hour. And so the change there, we know that this is our rate of change. So that means we know that it's going to be going up by 6 after every hour, because we're going 6 kilometers in every hour. So 2 hours will be 12, and 3 hours will be 18. We've got a table of values there. So what we can do now, we can graph that by plotting each of these coordinates. And because we're dealing with distance over time, we don't need to do our full Cartesian plane. We can just do a plane like this. So let's go with, make this one 6 here. Then we've got 12 and 18. Then again here we've got 1, 2, and 3. And this here is the origin, which is 0, 0. So now we can plot our points. So we know the origin is 0, 0. So that's our first one's going to be here. Oh, sorry, I've just done it white. Let's change that color. So first point is going to be here. Then we've got 1 hour and 6. So 1 on this time axis. So this axis here is going to be time. And this axis up here is going to be distance. So 1 on the time, that's be this one here, and 6. So our point is going to be around that bit there. Then we have a look. We've got 2 and 12. We've got 2 here. Let's fix that up. Let's go 2 here. And 12 here. And then we have got, here we've got 3 and 18 at the top. Now that we've plotted all those points, we can just connect the dots and will give us a straight line graph. So what we want to do now is write a rule linking D with T. So if we think back, the formula that we use to show our linear equations is y equals mx plus c. But we haven't got a y or an x here, have we? We've replaced those with our d and our t. So what we need to do, we need to replace our y and our x in our formula with our d and our t values that we've used. So if remember, our d was our distance, which we used on our y-axis. And then our t is our time, which we used on the x-axis. To replace d is equal to m. And then we've got t for time, t plus c. From there, we can solve to find the rule. So we know our m, isn't it? It's our rate of change. So our rate of change, how much is it changing? We know that it's changing 6 kilometers for every hour. So we're going to have d is equal to 6t plus c. If we think back, our c value is just our y-intercept. So to find what that c value is, you'll have to make your x equal 0. But we know we can just look at this table here. So if our x is our t, so where our t is equal to 0, our d is also equal to 0. So our formula is going to be d is equal to, it's just going to be 6t. Because if we add 0 to 6t, we still just get 6t. So that's the rule that we're going to have there. D is equal to 6t.